In this section, we are going to explore graphs of different functions. So some first things that we want to talk about is what makes a function a function. So the definition of function in general is that each input has exactly one output. So you could have order pairs as long as the x's don't repeat. We did do a vertical line test to test for functions. So those are some things that will help you remember what a function is. If you are still kind of confused about those, make sure you do go back to that section and rewatch the video and try some more of those problems. Something else that we've already talked about is the domain and range of a function. The domain is the set of inputs, and the range is the set of outputs. Typically, that would be the domain is the set of x values, range is the set of y values. We did talk a little bit about domain before, so domain, for instance, you need to make sure that you're doing square roots of 0 or positive numbers. You make sure you're not dividing by 0. So those are all things that will affect your domain and your range. For this one, we're going to be doing is a couple of things, but first we want to talk about what a graph of a function is, and it's the set of order pairs that make the function true. So what that means is if I were to substitute in the given x, y values of the order pair, I'll get a true statement for the function, or something that's true. So in the end, you come down to something like 2 equals 2. That's a true statement. A 0 is the x value for which the y value is equal to 0. So you're looking at, in other words of thinking of it, is the x-intercept. So we're going to start with that, and our first function is x squared minus 7x equal to 10. To find your zeros, you're going to set your y, or your f of x, equal to 0. So our problem is 0 equals x squared minus 7x plus 10. So we can factor this. If you either can't factor it, it's a function you can't factor, or you're not confident with factoring, another way that you could solve it is using the quadratic formula. You could also do completing the squares, although that is not nearly as popular. If you're multiplying and two things are 0, that means one or the other is 0. So if I add 5, I get x is 5, or add 2, x is 2. So what that means is if we were to look at the graph of x squared minus 7x plus 10, our graph looks something like this, and it's crossing at 2, and it's crossing at 5. We can also find these by using our calculators. So let me take a minute to bring up a calculator because we're going to use the calculator for our second example as well, but we'll do it with both of them so you get a sense of how to do it. First thing you're going to want to do is go to the y equals and substitute in your function. So let me bring this over so we can do that example, and then we'll go do the other one. So we have a y equals x squared minus 7x plus 10. Like we can look at the graph. If your window, so function doesn't show up in the window, so like mine doesn't, a common one that you'll want to do is zoom standard, which is zoom. So you do zoom and then go to 6. That'll bring everything to negative 10 to 10 on both the x and y axes. You can also change your window by just typing in values there. Now to find the zeros, you'll do second trace, which is calculate. And you'll notice here option number 2 is 0. Choose 0. Your calculator, what it's doing is you're going to set a left side and a right side, and it's just going to take values in between those two x values and substitute them in. So to set the left bound, make sure that you're going to the left of your 0. You can either use your arrow keys or you can just type in, like I can see 1 is definitely to the left of that first one. And 3 is to the right. push enter. It'll ask you to guess. That will only speed up the process. If you want, you can scroll over or you can just push enter. So we see here one of the zeros is 2. Repeat the process. A second calculate 0. Find the other one. 4 is to the left. 6 is to the right. And again, you can use the arrow keys. Guess I'm just going to push enter again and I get my second one of 5. So that's how we can do it on our calculators. Let's look at our next example. Our function is g of x equals square root of x plus 3 minus 2. So 0 equals x plus 3 minus 2. If we add 2 to both sides, and then we'll square. And then subtract the 3. So I get an x of 1. So if we take a look at this one on a calculator, make sure you know how to do both ways so that if you come across a function that you can't solve by hand, you have a resource for that. X plus 3 minus 2. Now my calculator has been updated, so your screen might look a little bit different. Make sure it is the x squared plus 3. And what I mean by your screen will look different is that y equals will look different. Split graph, and that's what our graph looks like. So we can check that 0 again by doing second calculate. Option number 2. To the left, well, it looks like 0 is to the left. To the right, to me, it looks, you got that line going across at 1, 2, so I'm just going to put in 4, even though we already know the answer, but that's okay. And then we have a 0 of 1. Remember, those zeros are the same as the x-intercepts. We also want to talk about what functions look like, and so they'll talk about increasing, decreasing, in constant functions, relative minimum, relative maximum, all kinds of good things about this function, about these functions. So our first function, we have example A here. We're going to talk about its behavior. So, and you would write this down. So it's increasing here. So it's increasing there to there, and it's increasing there to there. So it looks like it's increasing from 1, 2, 3, negative infinity. So all the way to the left to negative 3.5. And it's increasing again from negative 1.5 to infinity. It's decreasing here. Remember, I'm writing in an interval notation, so it's decreasing from negative 3.5 to negative 1.5. It's not a constant function. We'll talk about what a constant function looks like, but it's like a y equals 2, for instance. And then minimum and maximum, this is a relative max, because in that general area, it's up at its highest point. And this is a relative min. I should put relative so we know. So our next function, b here, we're going to look for, we'll start out, it's increasing on the interval from 2 to infinity, 2 and up. It is decreasing on the interval negative infinity to negative 1. Right here, that's a constant function. It's staying the same all the way across, and that's from negative 1 to 2. If we wanted to talk about maximum, minimum, and a relative maximum, there isn't one because these functions continue on forever. The overall maximum would be infinity because both of those sides, the left side and the right side, are getting bigger and bigger and bigger. And minimum, really we could have a minimum anywhere along this y equals 1, 2, 3, 4, 5. Y equals 5. If we have a function, we can do the same thing by using our calculator. So we have y equals x cubed minus 2x squared minus 3x minus 2. Yep. Again, your calculator won't make you do all this. It's better. I like the old way better just because I'm used to it. There we go. So we look at the graph. So I'll just do the little sketch here. So it looks like that. So this is where it is increasing here and here. And it is decreasing on this interval. This would be a max, and this would be a min. To calculate the average rate of change, we first need to talk about what does it mean to be average rate of change. A lot of times you'll hear average rate of change in regards to a distance, rate, and time. So the velocity or the speed would be your distance divided by your time, hence a rate of change. The average is where you're going between 2 points, so from the beginning to the end. So it doesn't matter what's going on in between. So if you're driving down the road, you look at your speedometer, it says you're going 30, and then, you know, you go through a few changes, right? You're driving along Highway 5. There's stoplights. At some points, you're stopped. Some points are going faster. Speed limit changes along Highway 5. And then at the end of the time that you're looking at, you look down at your speedometer again, and it tells you 50. So at the beginning it was 30, at the end it was 50. So you're looking for the rate of change just between 30 and 50. So to do that, you're going to basically find the slope between the 2 points. It's also called the secant line, and we'll do a couple of graphs to show you what that looks like. But ultimately, average rate of change is just the slope. So our first function is 3x squared minus 10. So we look at this graphically, we know it's going to look something like this. In the next chapter, we graph that. And then we're going to talk about what graphs look like. So for right now, if you're not really sure what the graphs look like, you can make an XY table like we did earlier in this chapter, or use your calculator to graph it and take a look at what the graph looks like. Then I'm going to identify ordered pairs at 1. So I know when x is 1, because this interval 1, 5 are the x values. I have 3 times 1 squared minus 10. So it's like -7. I know that my lowest point is going to be 0, -10. So I have 1, -7. And then at 5, I have 3 times 5 squared minus 10. So 25 times 3, that's 75, minus 10 would be 25. Now this is not going to be to scale, but we're going to draw it up here. So I have 5, 25. So those are my 2 ordered pairs, and every single time you'll want to find those 2 ordered pairs. Now, as I said, basically, the average rate of change is the slope between these 2 points. I'm sorry, 65. Lost track of what I was doing. So we're going to find the slope. So the average rate of change is the change in y, so 65 minus -7 over 5 minus 1. When I look at the graph of these, I want to just quickly evaluate what do I think the slope is. So it is, or I should say the line, so the line connecting those 2 points, so that's what we're looking for, is going up. So I know it should be a positive number, which I'll have 72 over 4, which is a positive number, so it's 18. Now, if this was, say, a speed or velocity, you could maybe write it's like meters per second or miles per hour, or it could even be dollars per hour if it was, say, maybe a wage. So just know that units may be on there. Let's do one more example to help solidify this idea. Now x cubed minus 7x plus 4, probably going to want to take out my calculator and look at that on here. So y equals this 3x squared, or cubed, sorry, minus 7x. Oh, let's clear it. Delete. Okay, so we have x cubed minus 7x plus 4. And again, remember my calculator might look a little different than yours. So it looks like this. Now I notice that it looks like it's kind of cutting off. This would be an example of what I maybe want to change the window. So I'm going to change my y values. I want it to go up to 14. I want that graph to show up in there. So graphically, it just looks like this. Now if you want to know where -1 is, I'm going to show you some tricks with your calculator. Well, let me do a couple of things at one time here. Let's go back to the calculator. You can do second calculate, and option number 1 is value. And I can type in, because I want to know what are the values at -1. And it's going to give me an ordered pair. So I know that f of 1 is 10. So f of -1 is 10. That's what my calculator showed me. And it did also show me where it is on the graph. And now if I don't do anything else, I can literally just type 2 and it'll give me the next ordered pair. So I have 2, -2. F of 2, oops, is -2. Another way to get those values on your calculator is to do second graph, which is choosing the table option. And the numbers will show up there as well. You might need to adjust your table. So if I do second window, that selects table set. So maybe I'm going to start at -1. And then the little triangle means delta, so change in the table up by 1. So that means each of my x coordinates are going to increase by 1. So that's another way of getting those values. Now again, really what we're doing is we're finding the slope of the line between those points. So change in y over change in x. So that gets me 12 over -3, which is -4. Make sure you evaluate your answer. So yeah, my line that I drew, which is called a secant line, does look like a negative slope.